Good morning, 7th grade. Welcome to day 2 of week 10. Today is May 27th, and we're going to continue with our understanding of angles that are formed when given parallel lines cut by a transversal. So we're going to click on the classwork tab. I'm going to scroll down to week 10, day 2. You'll see you have your lesson here. Couple of things. So not only is your lesson provided, there's also a support poster that I think was pretty cool. It's very student friendly. I feel like it really shows you which angles are equal to each other and which angles equal 180. So if you notice, the alternate interior angles and exterior angles, both of them, right? They're going to be equal angles. And then your corresponding angles, one's exterior, one's interior on the same side of the transversal, they are also going to be equal in measure. Then if you go down to consecutive, which means the same side, those angles are going to be supplementary, which means they add to 180. So if you notice, when you're on the same side of the transversal, if you pick the two angles inside, they will equal 180. And if you are on the same side of the transversal and you pick the two angles that are outside or exterior, their angles will equal 180. But the lesson today really shows you how to figure that out. So I'm going to get into that. I just wanted to show you that this was here as a support as well. And then of course there's another link that can help you out if you get a little stuck also. So I'm going to go into the lesson. I'll use my version since it's a little bit bigger. Okay, so given the diagram, we are asking you to identify the relationship that the angles share. So this was kind of like the exit slip that you had yesterday. I do apologize for my class. I put up the wrong exit slip. Your questions were supposed to only be like numbers 1 through 5, not 6 through 10. That's what we're looking at today. But I adjusted all of your grades to reflect that. I only graded you really on numbers 1 through 5 and not 6 through 10, since we didn't really talk about it too much in the lesson. But for those of you that did really well on it, regardless, today should be very simple because that's pretty much what we're focusing on anyway. So if we go over the warm-up, we can see the different angle relationships. So for example, angle 1 up here and angle 5 inside here would be corresponding. There's one outside, one's inside. They're on the same side of the transversal. And if you remember what I said, corresponding angles, I think of them just like sliding down. So 1 corresponds to 5. Angles 6 and 7, that's these two angles here. Notice they form a straight line. They are adjacent to each other, so they would equal 180 degrees, which means they are supplementary. Angle 2 and angle 4, they're opposite each other. They only share a common vertex. They're not next to each other, so they would be vertical and also congruent in measure, or equal in measure. Angles 2 and 8. So angle 2 is up here outside and on the right side of the transversal, and angle 8 is also outside but on the left side of the transversal. So these are alternate exterior. You then have 3 and 7. One's inside, one's outside on the same side of the transversal, so that is corresponding. And then we have our last set, 3 and 5. 3 and 5 are going to be your alternate interior because they are inside the lines, they're on different sides of the transversal, and they are also congruent or equal in measure. So a quick review of your vocabulary from yesterday. Now, what we're going to focus on today is finding the angle measure, and some of you already did so well on this yesterday, so this should be a breeze. We're going to start by just looking at the example provided here. So looking at this diagram, you should see that X is vertical to 110. We've practiced this before. When we have intersecting lines, the angles that share a vertex and are opposite each other are going to be vertical angles, and vertical angles are congruent or equal. So if this is 110 and X is vertical to it, then this angle here is also going to be 110 degrees. Okay, so how do we find the other angles? Well, let's put some letters to our other angles so it's a little easier for us to identify them, okay? So if this is X already, I'll make this Y, I'll make this Z, we'll make this U, V, W, and X. Just so that when we're going through them, I think it'll be a little easier for us to discuss which relationship we're looking at. Okay, so thinking about our vocabulary words and what we went over yesterday, you should see a few other relationships that are formed within our angles. So I'm noticing that angle X is on the inside of our parallel lines and alternate interior to that. So that means on the opposite side, never next to, would be angle V, right? And I'm also noticing that X is an obtuse angle, right? It's 110 degrees. So if I'm looking for the alternate interior, I know that they are the same measure. I also need this to be obtuse, which it is. Look at angle V, it's obtuse. Definitely greater than 90, but less than 180. So these two angles, X and V, because they're alternate interior, I can now assume that V is also 110 degrees. Okay? And then the last thing you can figure out, you can look at it different ways. There are many different answers that are acceptable for this. So we can say that V is vertical to X, and the same understanding we made up here, vertical angles are congruent. So if V is vertical to X, then X will also be 110. You can also say that angle, oh, did I use X twice? I did. Let's make this T. There we go. Okay, we can also say that angle T and X, they are corresponding. Look, I can slide X down the transversal and it would sit right on top of T. So we can also say that T is 110 because it's corresponding to X. Okay, so there's many different ways you can figure out and make a reason as to why you're coming up with the angle measures that you get. Now, what are we going to do about those other letters, right? We need to figure out what those are. So the other relationship that comes up is remembering supplementary angles. Supplementary angles means that they are two angles that equal to 180 degrees because they form a straight line. So if we look at the top, I'm going to assume if I put 110 together with Z, notice what happens. I create a straight angle, which we know is 180 degrees. So if this angle is 110, what can I do to figure out what Z is if when they're together they equal 180? Well, let's write that down. Let's see, 110 plus Z equals 180. So what can I do to figure out what Z is? I can simply just subtract 110, right? Solve my equation. Let's do it. And we're going to get Z equals 70 degrees. All right, so we got one of our angles that we need. So Z is going to be 70 degrees. Okay, now if Z is 70 degrees, what angle is vertical to Z? What angle is opposite Z? The angle that is opposite Z shares that vertex, but is opposite it would be Y. And if they are vertical, then they are equal in measure, so Y is going to be 70 degrees. Okay, now think about our other vocabulary words. What did we say? We know that alternate interior, right? So if I'm looking at Y, let me make this line here. What angle would be alternate, opposite, interior to Y? Well, X is already taken. We know that's out, so let's see. W would be alternate interior to Y. So we're going to call that also 70 degrees because alternate interior angles are congruent. And then the last one is going to be angle U. Angle U, we can say, is vertical to W. See how they're opposite? And when we have vertical angles, they are congruent or equal, so U is also going to be 70 degrees. And now we found all of our angle measures, okay? What I want you guys to notice is that in these diagrams, we only ever get two measures. Notice it's either 110 or 70. It's not 6 different measures because we have 6 different angles or 8 different angles. It's always only going to be 2 different measures. They're either going to be congruent to each other and be the same, or they're going to be supplementary to each other and add to 180. But when you are finding these angle measures, you should not get 8 different measures. They should only be 2 different angle measures. Okay, so that's figuring out this diagram using our vocabulary, which is super important for you to know. I'm going to show you another way that is kind of just a made up way, but I think some students find it a little bit easier to just make the connection. So I'm going to draw the same diagram we just had. Okay, I'm going to put 110 back here. We'll put X back here. And then let me put those letters back in. Well, I guess we don't even really need it. Okay, so this method is what I call the dot method. Now, this is like one of those things that is just made up. If you say to another teacher, oh, I use the dot method, they probably won't know what you're talking about. So just say you're using your understanding of the angles, right? But I call it the dot method. The reason why I call it the dot method is because what I do is I put a dot on one of my angles. So I'm going to make 110 a dot. Then I move in a zigzag motion and put dots where it falls on the zigzag. So I'm going to go cross, put a dot. Zigzag over, put a dot. Zigzag over, put a dot. So you kind of almost even make a Z if you think about a zigzag. Now, anywhere where there is a dot, the angles are going to be equal. Anywhere where there's no dot, those angles are going to be equal. And then anywhere there is a dot plus a no dot, that's going to equal 180 degrees. So what the heck am I talking about here, right? Okay, so let's see. So if this dot is on the angle, that's 110. Anywhere else I put a dot, it's also going to be 110. So that's going to be 110. This is going to be 110. And this is going to be 110. Anywhere there's no dots, it's going to be a different measure. And the way we can figure that out is by remembering a dot plus a no dot equals 180. And that's that same understanding we just did before, right? So I know that a dot, which let's say here, plus no dot equals 180. So that means 110 plus something equals 180, right? And we subtracted 110 to figure out what that other angle measure was. And we got 70 degrees. So that means that all of my no dots, anywhere that there's no dots, those angles are going to equal 70 degrees. So no dot, 70. No dot here, 70 degrees. No dot here, 70 degrees. No dot here, 70 degrees. And you kind of go even in like an inverse, like an opposite Z from before, right? And we get the same answer that we did using our vocabulary. So if the dot method is something that works for you to get those angle measures, go ahead and use it. It's perfectly fine. You do need to be familiar with the vocabulary, so I'm not saying to throw that out the window, but this is just like an easier way for some students to see it, to make that connection between the angle measures and how to find them. Okay, and everything we just went over is in the lesson 2. Notice I'm reminding you again, there should only be 2 different angle measures. We only have 110 and 70 throughout this entire diagram. If you get another angle measure besides the 2 you're working with, something is wrong. Okay, all right, so here's another example. We're given 37 and they want us to find X. So we can use the dot method, right? I made my dots. And notice that 37 does not have a dot, and neither does X. So that means they are equal to each other. So if 37 has no dot and X has no dot, they're going to be the same measure, so X must equal 37. We can also use our vocabulary and remember that 37 and X would be vertical angles because they are opposite each other. Okay? Then I'm finding other angle measures, so I use my dot method again. I filled in 37 wherever there was no dots, right? That's my red angles. And then to figure out what the dot measured, a dot plus a no dot equals 180. So that means my dot, which I did not know, plus 37 equals 180. If I subtract 37 from 180, I get what my angle would be wherever I have my dot. So that would be 143, and you'll see I plugged that in wherever I made my dots. Notice again, only two measures in my diagram, 37 and 143. Okay? All right, so then here's another example. The left side shows using the vocabulary, right? 120 is alternate exterior to x. Alternate exterior angles are always equal or congruent. So if 120 is up there and x is alternate exterior to it, x is also 120 degrees. If you use the dot method, we put a dot, we zigzag down, 120 has a dot, x has a dot, that means they're equal. So if 120 is up here and x also has that dot, then x is 120. Okay, so whatever method works best for you, that's what you're going to use to figure out these angle measures. Okay, here's another example. I'll do one more for you just to make sure we get it. Okay, so the lesson takes you through the vocabulary part of it, and then you can also use your dot method. You can even use the dot method if you want as a check, like just to make sure that you got the right angle measures. So 42 is here. Okay, if we wanted to find our other angles, I'm going to just fill in some letters to make it easier to identify when we're talking about them. So A, B, C. I'm going to actually give this one a letter, D, and then E, F, G, and H. Okay, so let's use our dot method. So I'm going to put a dot on A, and then zigzag down to fill in the other dot. So if A is here, zigzag, zigzag, zigzag. Okay, so anywhere there's a dot, they're going to be equal in measure. Anywhere there's no dot, they're going to be equal in measure. So I'm noticing that 42, which was the angle that was provided, does not have a dot. So anywhere that there's no dot, I'm going to fill in 42. So that would be angle B right here, 42 degrees. That would be angle H right here, 42 degrees. And then also angle F over here, 42 degrees. Okay, the lesson goes over the vocabulary you can use for this too. For example, you could say that D is vertical to B. Vertical angles are congruent. You could say that D is corresponding to H. So corresponding angles are congruent. You can say that F is alternate exterior to D. Alternate exterior angles are congruent. You can use vocabulary to support it as well. Now, to figure out what those other angles are that have the dots, we're going to subtract from 180. So we're going to do 180 minus 42, and that answer will give us the value of the angles that don't have a dot. So that value would be 138. And now anywhere we see a dot, we're going to put 138. So this angle would be 138. This angle would be 138. A dot, 138. And 138. And if we wanted to think about it vocabulary-wise, angle A and angle D are supplementary, right? They form a straight line, so they must add up to 180 degrees. So that's how you can support that this angle is 138. 138 is vertical to C, so angle A and C are equal in measure, so that's why that one is also 138. C is alternate exterior to E, so that's why they are congruent or equal to each other, and E is vertical to G, that's why they are congruent. Okay, so I hope that this made it a little clearer. The vocabulary for the angles are all provided in the lesson, and then I show you using the dot method like I just mentioned. And then you have your exit ticket. So it's going to be very similar to what you guys did yesterday, because again, I apologize that you got the combined exit ticket, but it should be easy for those of you that did really well with it yesterday, and I hope that it's easier for you now that you saw the lesson and the different options to find those angles. So if it helps, use the dot method. If not, just refer to that vocabulary. Remember which ones are equal in measure and which ones are equal to 180 when added together. Okay, so you'll answer the question, submit it, and that is all you need to do for today. I hope that helps. Reach out to me if you have any questions. Miss you.